Okay, in this video we're going to look at a couple more trig identities, basic identities, and then we're going to move on to proving some identities that don't look so obvious. Okay, so in this one here, more Pythagorean identities can be made from sine squared theta plus cos squared theta equals 1 if we divide both sides of this by sine squared theta. So these would need formal proofs, but we will assume that you can go through with those. So if we divide both sides by sine squared theta, then we get this. Okay, so we're just putting sine squared theta on the denominator on both sides. Okay, now the next step is to recognize that we have a common denominator here. We can break that up. So we can just write it like this. And sine squared over sine squared equals 1. Cos squared theta over sine squared theta, well, that kind of looks like sine squared theta over cos squared theta, but it is the reciprocal. And if we know that sine theta over cos theta equals tan theta, then cos theta over sine theta, which is the reciprocal, must equal cotan theta. So we can substitute these all in. So 1 for there, that's going to be cotan squared for there, and 1 over sine theta is cosecant. So this is the identity that we get. So this is another Pythagorean identity. Okay? And another one, if we divide both sides by cosine squared, okay, so if we take that and divide both sides by cosine squared theta, then we get this. We break that side up again, and we've got sine squared over cos squared over cos squared, and 1 over cos squared theta is just secant squared. So sine over cos is tan. This is obviously 1. And now we've got this as another Pythagorean identity. So we've got a cotan squared one with a cosecant, and a tan squared with a secant squared. Okay? So those are two more identities that we can use in our bigger proofs. Now we're going to look at some examples to prove here. So we'll start off with this one here. How about prove tan squared alpha over 1 plus tan squared alpha equals sine squared alpha. So we want to prove this. We don't know that it's true or not yet, so we can put a question mark over the equal sign if you want. So that's what you want to prove. So we're going to start with this one. We're going to start with the most complex side, so we're going to start with the left side. Okay, so tan squared alpha over 1 plus tan squared alpha. We need to put the word here, proof. So that's where it starts. And we're going to change the 1 plus tan squared to something else. So if we look back at what we just proved, we proved that tan squared theta plus 1 equals secant squared theta. So we could say that the 1 plus tan squared theta is now secant squared theta. Okay. So tan squared alpha over secant squared alpha. Okay. And we could change these around. Okay, so tan squared alpha, well, that just equals sine squared alpha over cosine squared alpha. Okay. And divided by secant squared alpha is divided by 1 over cos squared alpha. So we can change this to a multiplication, which becomes sine squared alpha over cos squared alpha times cos squared alpha over 1. Taking this and putting it over here. Now the cos squareds cancel out, and you end up with sine squared alpha, which happens to be what we want. So now we've got the right side. Okay? And therefore, we can write tan squared alpha over 1 plus tan squared alpha equals sine squared alpha. Okay? So that's one example. Here's another common one here. How about 1 minus cos theta over sine theta equals sine theta over 1 plus cos theta. So you want to prove that. Okay. So the proof, well, this one it doesn't look like it's advantageous to start from one side over the other, so we're just going to pick one side. So I'm going to pick the left side. Okay, so the left side is 1 minus cos theta over sine theta. And if we look back to our early on trig identities, we can see that this can work from one of our Pythagorean identities. So we look at here, we've got sine squared theta equals 1 minus cos squared theta equals 1 minus cos theta times 1 plus cos theta. So we've got a portion of this in here. So what I'm going to do here is a do nothing rule. I'm going to multiply the top and the bottom of this by 1 plus cos theta. Okay, and that's just like multiplying by 1, so I'm not doing anything really. And if I do that, then I'm going to be able to change the top. 1 minus cos theta times 1 plus cos theta is 1 minus cos squared theta over sine theta times 1 plus cos theta. Okay, and then we know that 1 minus cos squared theta from that same identity is equal to sine squared theta over sine theta times 1 plus cos theta. Okay, one of the signs cancel out, and then that equals sine theta over 1 plus cosine theta, which equals the right side. Okay, and therefore, okay, you've got that. That's true. So that's an identity. You could have chosen to go from the right side, and you would have multiplied the top and the bottom by 1 minus cos theta. Okay. Another option for this would have been to multiply the top and bottom by sine of theta. If you multiplied the top and bottom by sine of theta, then you would have had a sine squared theta on the top, and could have replaced that with a 1 minus sine theta, or 1 minus cos theta, cos squared theta, and then factored that. Okay, so there's a number of different ways to go on this, not just one way. All right. What if you had let's do an example here. This one here. So if you had this to prove, this one's ugly. Okay, then I would start from the left side on this one. And 1 plus 2 sine beta cos beta, well, that looks like the middle of expanding out a perfect square. So we're going to try and manipulate this that way. So look at the left side of this. Okay, I'm going to replace the 1 with sine squared beta plus cos squared beta. So that's replacing the 1 with that. And then just by rearranging this, putting the 2 part in the middle, well, that ends up being a perfect square. So you can factor that to sine beta plus cos beta squared. And then you cancel out one of the factors on the top with the bottom, and you've got the right side. So that's a hard one to see, but now that you've seen it, hopefully you'll be able to use that trick again. Okay. Now there are a lot of other identities that you can try and practice and solve. There's a website I found, and I'm going to just show you a little bit of it. So there's some trig identities on here with some solutions. Okay. And I'll just go through it slowly. Okay, so there's 18 on here. Okay, so if you need to pause it and write some down, then try them. And then I can go through here. There's another 18, another 20 actually. But we'll come back to that after. And then here's the proofs for them. Okay, so there's the proofs for them. And if you need to look at them, you can pause the video, slow it down. Okay, so that's the first 18. And then there's, without solutions to them, there are a second set of 20 problems here that you could try. Okay. So the first 18 are here. Okay, and that should help you with trig identities.